Hello everyone. In video 11, I missed out a very important feature, which is this one, the watch tab from the output window. So I need to use this video to demonstrate. So as an example, I needed to find some logic to demonstrate with the process. That's the one I choose to use one of the logic gate called NAND gate, right? So this is the circuit we wired before. Use the push buttons and the pilot light, and to implement the truth table of NAND gate, right? NAND gate is actually, you can see here, is not plus AND, right? So if it's AND logic, you should have 0, 0, 0, 1 as the output, right? And the combination is that. So the NAND gate is just the reverse event, the opposite of the output on that part, right? So we wire the circuit in the lab, and now we want to use PLC to do the same thing, to implement this truth table. So let me bring up the Studio 5000, and this is the logic we can use to convert what we have on the hardware circuit over here, which is IEC standard, but now we convert that into the PLC. All right, notice over here the S1 and S2, we use that as the push button, hardwired button. We just use different type of contacts. We use 6 different sets, right? So you can see that's the hardware solution. But with PLC, we don't need use so many different sets of contact. We only need one, right? That's for the hardware solution, right? But over here, I don't have the push button connected to my PLC. Actually, I don't even have a PLC. I just use the emulator, right? So like you can see over here, that's the emulator out here. So that's why over here the S1 and S2, they are just memory tag. All right, so they don't have the alias address to associate with the tag name. So you know that they are just memory, right, inside the PLC. All right, so now I can demonstrate where you can use the watch window on here. So actually, it's just at the bottom of your routine window. You can see here there are 3 different tabs. All right, I think in the different video I already talked about the errors, right? And then over here there's a watch. So if you click, you will see this watch window pop up. The other way, like I mentioned in different video, you can go to the view on the menu, and then there's option called watch. So that will also bring up this window. All right. So once you bring up this window, the problem is that over here, this is being set up as auto high as a default. So auto high, that means if you don't click this window and then you click somewhere else, that window just automatically disappeared, right? So that's not very convenient if we want to continue watch the tag value, right? So that's why over here you need to click this auto high, change to the, now you can change it to the docking, right? So that means the window gonna stay, right? So once you have this window open, and then you can set up what you want to watch, right? So over here there's a select pull down, then you can see the options on the list. Basically all the opening window will be appear on the list. Over here you can see this is the NAND gate, right? So this is the routine. Notice here, I have 2 routines open. So one of them is the NAND gate, the other one is called pump, right? So you can see here, because that window is also open, I can choose that on here, and then you can see that match up all the tags in that particular routine. But that's not what I'm demonstrating on this video, so I need to switch back to here. So same thing on here, so we can switch back. So you can see that's very convenient window for you to watch the the result of the value. So notice even though I click somewhere else, this window stays here. So what I want to look at here, this is perfect situation for us to verify the truth table here, right? So you can see right now we are looking at the first row, right? The input XY, actually we use that S1, S2, both are 0. So right now they are both 0 here. And then the output actually as the L1 is 1. So that's the first row. And then let's try to look at the second row. Second row, we want to change the S2 as 1, right? So that's why we can directly click here and type in 1. So you can see the highlights on the instruction change, but the output stays on, right? So that's right. That's that verify this second row, right? So now if I change the S1 from 0 to 1, that actually will match the last row. Both input are 1 and the output should be 0, right? So now if I change that to 1, enter, then exactly what you expect. The output L1 turns to 0, turn off, right? Well, we haven't verified the third row yet. The third row is the S1 is 1, S2 is 0. So now I can change this one to 0. Then you can see that turn back to 1 as the output, right? So this is again, you can see this is very, very convenient for us to monitor, to watch the tag values while we are doing that, right? While we are doing the programming, troubleshooting, debugging. All right. So while we are on here, I need to demonstrate. You can see. Let me zoom out a little bit. So back then, when we wire the hardware circuit, not only we have one solution, they can see on top of here, we also have a second version here, and this is the number 3 version, right? So we can use the same sort of technique to convert that into the PLC logic, right? So I can do it here. If I do the Control C and Control V, you can see I directly edit, insert. I'm using the online edit, right? So directly copy another one. So I want to match up this one, right? So there are 2 branches. So I just need to delete that, and then both should be exam off, right? So I just need to delete this and delete this. That will, you can see, match up the solution on here. And the output, we don't want to use the same output. That be the double coil, right? So we need to create another one. Use the L2 to represent the second output, so we can see we should have the same result. And notice here, because I didn't properly create the name L2 as a tag, you can see right now it shows undefined, and that's why over here it shows error, right? So as I demonstrated before, you can right click L2 and then just create. So that's the creation of the tag. And notice here the error is gone, but we're still in the middle of the online edit, right? So we need to click the finalize to get the everything settled down, right? So over here we have the second logic, second solution turn on. So now we can use the watch window, right? So you can see right now that's the old view, right? It doesn't have the L2. Let me zoom out a little bit. So on the watch window, if we want over here, there's a refresh, right? If you refresh, you can see here L2 pop up, right? So we can just quickly verify that. If we turn both to 1, both to turn out 0, right? And if we, oh, sorry, over here I made a mistake. I didn't change the tag value, tag name, right? So this one should be S2. I wonder why we didn't have the same result. So quickly we can finalize, So now we can, this is error window, right? You can see here. So don't worry about that, right? This is one of the tab. We can click watch. So now L1, L2 should have the same result. Right? If we change the S1 to 0, they are both 1. And then change both to 0, yeah, you can see as I go, everything, the L1, L2, they are the same result, right? So then let's continue with the third one. If we do the, let's do over here, add another one. All right, so we can use the both input. We can drag to here. That's the other quick way to create a tag. So now over here we need to have a K2 as an intermediate result, right? As you can see, this is the third solution. K2 is the intermediate logic result as the AND, right? So I can create a tag. I can call the K AND, right? So if we want to memorize that as the intermediate result, right? And after that, I can create a new tag on here, new run, and then use the exam off from here, right? That's basically a match up on here. Then the output will be the new tag we can create as L3. So we have 3 solutions now. Then don't forget to finalize. So now we have the window open. Let's see here. We can move that window down a little bit and refresh. So we'll see 3. I have to zoom out a little bit. All right. So you know that's the logic. Then we can see the whole routine on here. So you can see that even have the K, the end on here, L1, L2, L3, and let me move up a little bit. So S1 and S2, you can see L1, L2, S3, they all turn on now. So if I change this one, S2 to 1, they should all turn off. Right, so you can see all 3 zeros on here. Right, if I turn the S1 to 0, and so on and so forth, you can see I can verify all the 4 combinations with this way, right? So again, very good technique, a very good tool for us to monitor and modify the tag values, right? So this is the end of this demo.